We present Open3DSG, Open Vocabulary, 3D scene graph generation from point clouds with queryable objects and open set relationships. Given a point cloud of an indoor scene, recent methods use supervised learning to predict 3D scene graphs with node and edge predictions that are limited to a small closed vocabulary defined during training, limiting the expressiveness of the scene graph representation. In this work, we investigate the question of how to generate open vocabulary 3D scene graphs, where not only object classes are open vocabulary, but also the relationship descriptions between the objects. A popular approach for open vocabulary classification is CLIP. CLIP trains an aligned vision and text encoder and uses the cosine similarity between the text and image embedding to find matching class image pairs. However, when querying CLIP for compositional concepts such as relationships, CLIP yields poor results. This phenomenon was studied extensively in this iClear work. Therefore, we utilize CLIP only for object node prediction, but investigate other approaches in this paper for relationship prediction. Instead of utilizing CLIP-like models, we investigate vision language models with an image encoder and an LLM as the decoder. By using an LLM model, we utilize all the compositional and world knowledge embedded in them, resulting in improved relationship predictions. The basis of our work is the instruct-blip model. We cut the connection between the vision encoder and the LLM and distill the features from the vision encoder into our Open3DSG model. Our model processes a point cloud and outputs a structured feature graph representation of the scene aligned with the LLM. The LLM then processes the feature graph together with a language prompt to predict an open vocabulary 3D scene graph for the 3D scene. In detail, our approach trains a 3D graph neural network which processes a 3D point cloud and embeds the scene as a feature graph. Since CLIP performs well on objects, we learn open vocabulary node embeddings by distilling features from OpenSeg using a cosine similarity loss applied on aligned 2D frames. For relationship embeddings where CLIP-like models struggle, we distill features into the graph edges from our LLM-based approach by embedding images showing pairs of objects using the image encoder from instruct-blip. At test time, we predict the final scene graph in a two-step process, either from 3D data alone or from a 2D-3D ensemble. We first query the nodes using encoded CLIP text prompts based on user-defined classes. In a second step, we then pass the predicted node classes together with the perceived edge features into a Q-former and LLM, together with a relationship prompt to finally predict the relationships for each edge in the 3D scene graph. Our open vocabulary model is able to predict detailed 3D scene graphs with highly descriptive relationships, such as the TV mounted on the wall here. When evaluating our model on the popular 3DSSG benchmark, we see large improvements for predicate and relationship prediction when comparing the CLIP-based predictions with our LLM-based scene graph predictions. We see further improvements when using a model trained with 2D and 3D data instead of a model utilizing 2D features alone. Similar to most open vocabulary approaches, our model still falls short of a fully supervised approach trained specifically on the benchmark classes. We aim to close this gap in the future. Given the open vocabulary nature of our approach, we are able to predict other scene understanding and reasoning tasks without fine-tuning our model. To this end, we can, for instance, predict describing attributes for objects in the scene graph. Or we can perform simple inter-object affordance reasoning by prompting the scene graph conditioned LLM with questions such as if you could lift an object like the pillow from the bed or the bed from the floor. Thank you for watching.